In this example, I set the timer such that it produces a delay of 10 seconds. I then adjusted the time delay to 1 second by varying the potentiometer. Next, I tried out the manual reset feature, which can be used to reset the timer during the timing cycle. You will need the following components to make this circuit. Now let's take a closer look at the 555 timer IC. The 555 is a highly stable device for generating accurate time delays. Additional terminals are provided for triggering or resetting. The circuit may be triggered and reset on falling waveforms, and the output circuit can source or sink up to 200 milliamperes. In the monostable mode, the time is precisely controlled by one external resistor and capacitor, and the 555 acts as a one-shot pulse generator. The pulses being when the LM555 timer receives a signal at the trigger input that falls below a 1/3 of the voltage supply. The width of the output pulse is determined by the time constant of the RC network. The output pulse ends when the voltage on the capacitor equals to 2/3 of the supply voltage. The output pulse width can be extended or shortened depending on the application by adjusting the R and C values. The external capacitor is initially discharged by a transistor inside the timer. Upon application of a negative trigger pulse of less than 1/3 of VCC to pin 2, the internal flip-flop is set, which both releases the short circuit across the capacitor and drives the output high. The voltage across the capacitor then increases exponentially for a period of t is equal to 1.1 RC, at the end of which the voltage equals to 2/3 of VCC. The internal comparator then resets the flip-flop, which in turn discharges the capacitor and drives the output to its low state. The schematic shows how the external components are connected to the LM555. You can find the schematic, PCB board layout, and the full explanation in the link in the description. Next, I made a PCB using the iron method and began placing the components onto it. The LM555 has a maximum typical supply voltage rating of 16 volts, while the relay's armature coil is enabled at 12 volts. Hence, a 12-volt power supply is used to minimize the number of components, such as the linear voltage regulator. If pin 2 of the LM555 is triggered by shorting it to ground through the tactile switch S1, the timer is started. The timer generates an output pulse with an on-time period determined by the RC network. In this case, the fixed value of the capacitor C3 is 100 microfarad. The value of R consists of a 10 kilo ohm resistor in series with a 1 mega ohm potentiometer. We can vary the potentiometer to change the time period of the output pulse. For example, if the potentiometer is set to 0 ohms, the total value of R is equal to 10 kilo ohm. Hence, the on time is 1 second. Similarly, if the pot is set to 1 mega ohm, the total value of R is equal to 1 mega ohm plus 10 kilo ohms, which is equal to 1010 kilo ohm. Hence, the on time is 100 seconds. When pin 4 of the LM555 is triggered through the tactile switch S2, the timer is reset. When the timer starts, the relay turns on. Hence, the common terminal of the relay is shorted to the normally open terminal. A high power load can be connected to this terminal, such as a light bulb or a water pump. The transistor Q1 acts as the switch and ensures sufficient drive current is provided to the relay. Diode D1 acts as a flyback diode, which protects the transistor Q1 from voltage spikes caused by the relay coil. LED 2 turns on in order to indicate when the relay is turned on. LED 1 indicates that the circuit is powered on, and SPDT slide switch S3 is used to switch the circuit on. Capacitors C2 and C4 are used to filter noise in the supply line. I then soldered all the components into place, including the screw terminals meant for the power supply and load. I connected a 24-volt DC indicator light, which acted as a test load between the relay's normally open and common terminals. When the timer switches on, the common terminal is shorted to the normally open terminal, thereby completing the circuit. If you learned something from this video, don't forget to like and subscribe. Tag me on Instagram if you managed to make this timer. The circuit schematic, PCB layout and Eagle files are open source and can be found in the link in the description.